Hey guys, we are Caesars Bridge and this video is about our Fed Project 2016.
To start off the design process, we researched bridge types. We decided to go with an arch bridge because arches are strong, they use little material, and have withstood the test of time. We decided to develop our bridge design in AutoCAD. The picture behind me is the finished design we took to the wood shop for the first time around.
When we got to the wood shop, we started cutting our joints and we realized that they just weren't going to work. They weren't flush, so they didn't fit together well, and we went back to the drawing board.
Our next design consisted of a beam bridge that was fit together with similar joints, and we went all the way through this design cycle for the idea.
When we tried to test it with weight, we found that the beam bridge also wasn't going to work with our design because of simple angles and the forces placed on our bolts. Behind me is a picture of a bolt which bent during testing.
After seeing this design failed, we decided to revert back to our arch design and refine it so it would be simpler to assemble. Instead of our sharp angles and bolts, we decided to go with joints that would be attached by two dowels.
Once we had already drilled out the holes for the dowels, we found that it was impractical to drill the holes and they just didn't fit right.
We decided to scrap the dowel idea and decided we needed something to hold the pieces of wood together firmly, but also be detachable. After some thought, we got the idea of using clasps from a toolbox, because toolboxes are held together tightly, but can also be quickly released. After many phone calls, we found out that our local Lowe's carries an item called a draw catch that is pictured above. These draw catches were held on by 3 screws on each piece. They seemed to be very durable. The next part of our design was deciding whether to use a ratchet strap or something lighter as a tension cord across the bottom of our arch. Ratchet straps are very strong, but they're also very heavy. So instead, we decided to use 500-pound test paracord. Paracord is very light and also supports a lot of weight, but using it meant that we needed to figure out knots that would work in our situation to quickly tension and assemble. We knew from prior knowledge that a double figure-8 knot can be used to support a lot of weight because it was used for rock climbing. And with a quick search on Google, we found a knot called a taut line. This taut line can be tensioned very quickly, but also holds fast under load. After assembling our bridge, we added wide feet on each side to keep it from tilting.
After we added the feet, we realized that our pieces no longer fit in a 1 foot by 1 foot by 1 foot box. So we consulted our project guru and asked if we were allowed to bring a drill so we could screw the pieces together on Fed Day. All in all, the constraints for the project, along with the general task of woodworking, made this project quite a challenge.
So now we get to talk about Fed Day, but before we start, we're going to show a short clip of how it went.
As you can see by the video, our project did pretty well at Fed Day. It held 110 pounds before failure, and we met all the requirements. Our bridge weighed exactly 8 pounds, which was the most it could weigh, and it spanned exactly 4 feet. The only thing we had a problem was the judge questioned us about using our drill and the screws during assembly time, but we explained to him that we talked to our guru and got it checked beforehand.
So things we could do differently. One of the first things are these draw catches. These draw catches, when we first placed them on each of the joints, we had pushed the 2 pieces together and then traced our holes. And what that did, it made a little gap between these little metal rings. So if you unsnap it, you can see this little metal ring has a little gap between its the thing that it snaps to. And what that does, gave us room to have like a bend kind of pressure on all of these little rings. And that's where our bridge actually failed, if you saw that in the video. And another thing we could have done differently, we designed the bridge to be 11-degree angles, which is sharper than what we could have done. 11 degrees actually made us come up 1 inch short for our 4-foot goal, and we had to use these feet and attach them by L brackets to give us that extra inch and also keep it from tilting. In our first design, we had feet that were placed on that would still fit in the 1 foot box, but since we had those sharper angles, we had to make something that was detachable, and got the flack from people because we had screws and brackets and everything. But if we could go back, it would have been better to use a 10-degree angle and spanned just about an inch more, and that way we wouldn't have had to have screwed anything in on Fed Day, and it would have been a lot better of a process.
Yeah, so overall, Fed was a great experience for all of us, and we learned a lot, and we saw some great projects.
If I had to recommend anything for freshmen that were starting this project, I would say the most important thing is to meet very frequently and start meeting early on. Because we met immediately, like the day after we found our groups, and we kept that dynamic, and we finished before most projects did. Another thing I would say would be not to be afraid to just build your prototype and test it instead of like pondering over 2 different things and like trying to work out really intense math. Just put it together. It won't take that long. All the guys at the wood shop do the work for you, and just put some weight on it.
One other thing is make sure you clear any questions you have with your guru or your teacher beforehand, just to make sure that you're in the right and you know what you're doing and you have an idea going into Fed Day. Also, be sure you use all your resources. We did the majority of our work in the wood shop at the Craft Center, which worked really well for us. Just make sure you know where you can go to get your project done.
This has been Caesar's Bridge.
We wish all of you engineering students and incoming freshmen good luck.
This experience has been great and we've learned a ton.
Thanks for watching.